This is 3.3 exponential derivatives. So with an exponential derivative, what that means is that the exponent is a variable. So this is a variable. And the base is a constant. So often people look at this and they see number with an exponent or something with an exponent and they want to do the power rule. The power rule is different. The power rule, the base is a variable and the exponent is a constant. So when the base is the constant and the exponent is the variable, we have a different rule. And that rule is to copy over what you have written and then take the natural log of the base. So let me write that out here. So copy function and then multiply by natural log of the base. So if we have something like 2 to the x, we're going to copy it over. So 2 to the x. And then I'm going to multiply by natural log of 2. If I have something like 1/4 to the x, I'm going to copy it over. So 1/4 to the x, and then natural log of the base, the 1/4. Sometimes you can do these problems in two different ways. For example, for this next one, I could use the property in exponents that says move your base with the exponent to the denominator. So I could rewrite this as 1/3 to the x, which is equivalent to 1/3 to the x. And I can treat it just like the example we just did. I can say y prime is equal to 1/3 to the x times the natural log of 1/3. I could also treat this like the chain rule because it's 3 to an x that is something other than x. So I could say that my outer is 3 to the something, and the derivative of the outer was 3 to the something natural log of 3. And I could say that the inner is negative x, and the derivative of the inner is -1. And so therefore, my y prime would be 3 to the negative x natural log of 3 times -1. So it just depends on how you see it. Let's take a look at the next one in a similar way. So 1/5 to the negative x power is the same thing as saying 1/5 to the negative x, because 1 to any power is still 1. So 1 to the negative x is just 1. And then I could write this as 5 to the x by moving the thing with the negative exponent from the bottom to the top. By doing that, then I could say f prime of x is 5 to the x, and then natural log of 5. If I wanted to treat this as a chain rule problem, I would say my outer is 1/5 to the something. Then the derivative of the outer is 1/5, rewrite it, to the something times natural log of 1/5. The inner is negative x, and the derivative of the inner is -1. So then f prime of x would be the derivative of the outer, so 1/5 to the exponent, so negative x, times natural log of 1/5 times -1. So it just depends on what you see and how you would like to approach it, whether you do some of the legwork on the beginning to try and rewrite your function so that it looks like the two examples in pink at the top of the page, or whether you see it as a chain rule problem and would prefer to do your legwork using the chain rule. So in general, when you're doing the chain rule with exponential functions, it's helpful to think of this as, whoops, the derivative being, I'll write this off to the side, rewrite it, natural log of the base, and then derivative of the exponent. So if we follow that rule, and this should just be g of x, that's a little typo, g prime of x is going to be, rewrite it, so 6 to the 2x, natural log of the base, so natural log of 6, times the derivative of the exponent. And you don't have to write it out like that, but I'm showing it so that when you look back, you know that we took the derivative of the exponent. So that's going to be 6 to the 2x, natural log of 6, times 2. And then it looks a little funny because it could be like people want to make that natural log of 12. They see the 6 times 2. So what we tend to do is bring that 2 up front and then write it like this. So same thing is going to happen with the next example. We're going to say dy dx. And we could do this with inner, outer, dinner, doubter. Like if we wanted to, I could say outer is 5 to the something. Derivative of the outer is my exponential derivative. So 5 to the something, natural log of 5. Apologies for my dog. And then the inner is x squared. Derivative of the inner is 2x. And so I could write 5 to the something, that something is x squared, so rewriting it. And then natural log of 5 times the derivative of the exponent. And then to clean this up, I would say 2x and then 5 to the x squared, natural log of 5. Okay. The next one has a root, so we have to do a little rewrite. We have to make this 4x to the 1/2. So again, I'm going to say h prime of x. I'm going to copy this over, so 4x to the 1/2, natural log of 4. And then I'm going to take the derivative of x to the 1/2. So the 1/2 comes down in front. My exponent becomes a -1/2. And cleaning this up, I have to fix that negative exponent. So I'm going to leave the 4 to the x to the 1/2 up top. The natural log of 4 stays up top. The 2 and the x to the 1/2 go down in the bottom. For the next example, same deal. I'm going to write dy dx. Copy over my problem, so 2/3 to the x cubed minus 4x. Then I'm going to write down natural log of the base, so natural log of 2/3. And then the derivative of my exponent, which is 3x squared minus 4. And to clean this up just a little bit, it's hard to clean up exponential stuff, but I'm going to clean it up just a little bit. I'm going to bring the 3x squared minus 4 to the front, and then 2/3 x to the third minus 4x, and then natural log of 2/3.